Hello and welcome to this tutorial, an introduction to event sourcing. My name is Duncan Jones. My contact details are in the top right hand corner of the screen. Please do get in touch if you have any questions or feedback. The agenda for this course is that we're going to start out with describing what event sourcing is, move on to why you would use it, and finally how you would go about using it. This course is the first course, it's ideas about event sourcing. Later we will move on to how you model things with events, that feeds into event sourcing, and finally how you use code generation to write the code that will underpin your event sourcing system. Some brief notes about this course. In this particular course there will be no actual programming language shown. Event sourcing itself is an idea that can be used with a wide range of programming languages. I myself use C#, but it works particularly well with functional programming languages, the likes of F#, Scala, and so on. The second thing to note is that this course is very much aimed at a beginner level. So I will be introducing the concepts in this particular course, and I do not really expect you to have or to require any particular background. So let's get started with a simple definition of what event sourcing actually is. What I'm going to use here is a really very simple hello world example which represents a bank account. I'm going to compare how this would be done in a CRUD based system, sort of a database backed system, versus how you could do this in event sourcing. So let's start with a table based example. We open our bank and we basically have one table. I did say that this was very much a simplified example. So we start with an empty table. This is before any transactions have occurred. Then our first customer comes in and they open their account with an opening balance of $10. So this first line is inserted into the table, account number 1, Aidan, balance of $10 and the last transaction date. Then we imagine that his sister Margaret comes along and she also deposits the same amount of money. So account number 2, Margaret, $10 on the 21st of January. And finally her brother Fergal, on the way to the bank he's actually managed to spend $5 of his dollars, so he deposits just $5. And that gives us the state of play at the end of the first batch of transactions. Let's imagine then on our second day that Aidan comes along having seen what Fergal has bought and decides that he would also like that, and he then withdraws $5. Margaret, having seen the way that this bank is being run, decides that she'd rather not have anything to do with it and withdraws her whole amount and closes her account. And there you can see how this looks at the end of the second batch of transactions. The advantages of a table-based system, as you can see here, is that at any given time you can see the full state of play of your system. You can see amount held, the number of bank accounts, and so on. The disadvantage is that you have lost quite a lot of your data there. You've lost the history of your data. In the real world, you would batch this up with transaction tables and so on. But what I'm going to show you here with event sourcing is an alternate way of doing that. So in an event stream based example, what you do is rather than record the current state of each of these accounts, you record all of the events that go into creating the current state. So to go through exactly the same example again, we start out with Aidan. He comes in, he opens his account, that's the first event that goes in, and he deposits $10. In this system we've actually broken what in the real world appears as one event into two distinct event types. So opening an account and depositing money. This allows us to look at, for example, opening an account without a deposit. Margaret comes along, she also opens an account and deposits money. And then Fergal comes along, he opens his account and he deposits his money. So exactly as we were before, we have the end of the first batch of transactions. Then Aidan comes along as before, withdraws $5, so we add a withdraw money event onto his stream. Margaret comes along and she's closing her account, so we put in a withdraw money event and a close account event. So at this stage you can see that what you basically have is an entire life history of your data. You can see the events that have occurred for any of the three depositors, and you can see the order in which they've occurred. It's very easy to see the data going in, and as you can imagine, this data can be written in parallel. But a problem arises here in that how do you get the data back out of this? This brings us on to a piece of code called a projection. Projection is a very simple piece of code. It has two functions. The first is to filter by event type, and the second is to decide what action to perform when you encounter that event type. In this example here, we have a projection that is going to give us the running balance. So for an open account event, we simply skip over that event, take no action. For a deposit money event, we increase the balance by the amount of money in the deposit money event. And for a withdraw money event, we decrease the balance by that same amount. So to show you this in action, after the deposit money account, the account has $10. After the withdraw money account, the projection has a value of $7. Now there are some rules or constraints when you are using event sourcing. The first rule is that the event sourcing is immutable. That means you're not allowed to delete, edit, or reorder any event once it's been put on the stream. The event sourcing stream can be seen as an append-only data type. Now, obviously you're going to be wondering, well, what if a mistake is made? How do I go about undoing a mistake? And the way this is done in most systems is that you would have a compensating event. So, for example, in the case of a withdrawal or a deposit, you could have a rebate or a cancel and rebook event. The idea with that is that you basically get back to your state that is correct by fixing up events after the error. The second rule is that your event stream is the source of truth. So events on the event stream are facts that have happened in your system, and if you want to rebuild the current state or the state as at any given time, you rebuild it from the events themselves. So, we've shown what event sourcing is. Now let's take a look at why you would actually use this within a computer system. The first difference between event sourcing and a database or CRUD-backed system relates to how they scale. As each event stream for each entity is logically isolated, it is possible to operate on them in parallel without the need for sophisticated orchestration. This makes it easy to scale up or down by adding hardware. This is known as scale across in comparison to scale up. You do, however, have to be aware of the concept of eventual consistency. Eventual consistency arises from the fact that it's possible for events to be added to the end of an event stream while a projection is running over that same stream. Depending on which operation completes first, this added event may or may not be included in the projection. To mitigate this, the projection needs to be modified to return the last event processed, as well as the evaluation. Subsequent runs of the projection can start by processing events that have occurred since this last recorded position. This ensures that every event is included in the projection eventually, hence eventually consistent. As long as you're aware of eventual consistency and can code your logic accordingly, this is not a major problem, and indeed in most cases eventually is actually a really short period of time. Another area of comparison as compared to, say, a CRUD-based system is in terms of business fit. Some businesses are an obvious fit for an event source model, those that are already ledger or transaction based, such as banking or insurance. For less structured business, you would need to perform an event-based analysis phase to discover the actual domain events and entities that you should be capturing in your system. In my experience, it is less disruptive to add a new event type to an event source system than it is to modify a table-based system by adding new tables or fields. Indeed, it could be said that an event-based system evolves to change somewhat linearly, whereas a relational system evolves more exponentially. In terms of developer experience, the biggest difference is the mindset change from a state and relational model to a more changes and history-based model. The generated code for an event-based system is usually straightforward, and it is possible to have quite a strict separation between the business code of the events and projections versus the implementation code of the event streams. I will show the generated code in the third part of this tutorial, but it is certainly not more difficult than the code of an equivalent model-based application. Event sourcing is often discussed in the context of the command query responsibility segregation architecture. Although neither is strictly dependent on the other, they do certainly fit well together. On the command side, the end result is one or more events being appended to one or more event streams. The query side can get its data by running projections over the event streams and then performing any collation or aggregation functions as required. Queries can be executed directly, or they can run against prior generated results stored in a cache. When it comes to using event sourcing with microservices, and more particularly with domain-driven design, my recommendation would be to keep the event stream private to one given domain, and only to communicate between them by way of defined commands and queries. This prevents the domains becoming locked together by having to share the event definitions and access to that underlying event stream. So that is the what and the why of event sourcing. I will cover the how in detail in the next two parts of this tutorial, first showing how to model event-based systems, and then looking at using code generation to rapidly assemble an application based on event sourcing. For now, I will leave you with some recommendations. The first suggestion I have, if you're new to event sourcing, is to do some experimentation. Set yourself a small Hello World type of application and work through it using event sourcing for your data persistence. Do this before you start with it in a live project so that you can discover any potential pain points for yourself. There are a number of good blog posts on event sourcing, and I would also recommend viewing the YouTube videos by Greg Young and Yudia Han, amongst others. It's also worth following them and also Daniel Whitaker on Twitter for more new developments. For production systems, you could use an event sourcing system such as EventStore, which you can find at www.geteventstor.com. You could also use a solution such as Azure Event Grid to build a cloud-hosted enterprise system incorporating event sourcing in the mix. Finally, for .NET developers, there's a CQRS designer which I have put together for designing and code generation of the boilerplate code for an event sourcing system. This can be found on codeproject.com. That concludes this introduction to event sourcing. I hope it has been useful. My contact details are at the top of the slide if you have any questions or feedback.